Okay, in this video we're going to go over Lesson 5, Solving Equations Involving Logarithms. There is a warm-up that I'd like you to try. I'm going to ask that you just skip number 5. So please take a couple of minutes to try 1 through 4, pause the video. You're going to solve for x by converting into exponential form, which means you're going to be using the loop trick. Circle the base, run the race. Okay, so pause the video, give each one of them a try, and then we will go over it. Okay, so if we take a look at number 1, I want to solve for x here. If I use the loop trick, I would go into exponential form, which would be 3 to the x is equal to 27. And the way that I would solve this exponential equation is by coming up with a common base. So on the right side, rewriting 27 as a base of 3 to the third power. And what that allows me now to do is recognize that x is equal to 3, since they are both the exponents of that common base of 3. Now, this logarithm could have been completely just typed into your calculator. We're just really practicing the loop trick, but since everything attached to that log is a number, you could have typed in log base 3 of 27 and confirmed that it was indeed 3. Okay, let's try number 2. So circle the base, run the race. We have 4 to the power of x is equal to 1 over 64. Again, we're solving this by common bases, so we want to get the 64 to be a base of 4 if we can. So if we think of it as 4 to the third, which is what 64 is, we would just need to get that out of the denominator so that it's a base of 4 by making that a negative 3 in the power. And again, this was a logarithm that was entirely numerical, so if you had typed in log base 4 of 1 over 64. Let's do this one in the calculator just to review how to do that. Alpha window 5 is log base. So if we typed in a base of 4 and then the input is 1 over 64, you'd confirm that that answer is negative 3. Okay. Now for number 3, to use the loop trick, we have to remember that that is a common log. So there is a base of 10 here that we need to know is there. So circle the base, run the race. So we have 10 to the x is equal to 0.0001. And if you think about, excuse me, if you think about this number, if I want to get it into a base of 10, like scientific notation, that would actually be 10 to the power of negative 4, since I'd have to move the decimal place over to get that back to being a base of 10. So this gives me an x value of negative 4. And again, you could type that in, common log of 0.0001 to confirm that you're getting negative 4. And now the last one, number 4, I'm going to circle the base of 3. This is really the first equation here where we did not have a logarithm that was entirely numerical. This is the first one where you would not have been able to just type that in because there's an x inside of the log. So really for this one, it's showing you that you need to use the loop trick, whereas the other ones you really just could have typed them in. In order to solve for x, you would convert into exponential form and get that x is equal to 9. Okay. So now what we're going to do today is we're going to really use this logarithm loop trick, but we're going to be going the other way. We're going to be solving exponential equations using logarithms. So if you take a look at the steps, we're going to be isolating the base. Again, that's the number being raised to the variable power, converting from exponential form into logarithmic form, and then evaluating that logarithm. So in our last unit, when we solved exponential equations, we only had one method, and that was the method of common bases. But it won't always be the case where you can come up with a common base. So if you look at, for instance, number 1 here, I have one side of my equation is a base of 9 being raised to the x. The other side is 14. And there's no way I'm ever going to be able to get 14 or 9 to be written in terms of the same base. So we already have the base isolated. So we're going to circle the base of 9, run the race. Now remember, we're going from exponential form into logarithmic form, so this is going to become a logarithm with a base of 9 of 14, and it's equal to x. Now this logarithm is entirely numerical, so now what we can do is go to the calculator. Alpha window number 5 is log base, a base of 9, and what's inside of the log is the 14. So we get 1.20108, and they're asking us to the nearest hundredth, so 1.20. So prior to this lesson, or prior to really understanding how to convert from one form to the other, we would not have been able to solve an exponential equation like this since we were not given another method prior to knowing how to use logarithms. Okay, so for number 2, we're going to isolate that base. So we get 5 to the x is equal to 18. Now we're ready to convert forms. So we get a log with a base of 5 of 18 is equal to x. Now we can type this in. So alpha window 5, log base 5 of 18. And again, we're rounding 2 decimal places. So that 5 would round up the 9, which would round up the 7. So this should be 1.80 to the nearest hundredth. Okay, number 3. The base of 2 is already isolated. So circle the base, run the race. So we have a log with a base of 2 of 15 is equal to that exponent, 2x minus 1. So the only thing on this one is I have a few more steps to do. So I could type the log in now, but it's always good to wait to round until the end. So a log base 2 of 15, all that is a number. So I'm just going to leave that for now until I get x by itself, and then I'll just go type the whole thing in. So x is equal to whatever this log plus 1 divided by 2 is. So if we want, we could even type that all in at once. So alpha y equals enter. Let's type it in using a fraction. Excuse me. Alpha window 5 gets me the log base. So log base 2 of 15 plus 1. Let's get out of the log parenthesis before we type the plus 1, and it's all over 2. So again, rounding 2 decimal places, I should get 2.45. Again, you could have broken those steps up, but you just want to round at the very end. So you wouldn't have wanted to type that log in earlier and then round it and then add 1 and divide by 2. You want to make sure you wait till the very end to round. Okay, last question here. This one's multiple choice. I'm just going to zoom in for a second on the question. So we're going to want to isolate that base of 2. So step 1, we're going to divide by 8. So we get 2 to the power of x plus 3 is equal to 6. Now we're ready to convert forms. So we have a log base 2 of 6 is equal to x plus 3. And then we'll just subtract 3. Now, with this question, we did get the answer, but when you look at all the choices, there's actually no choice that matches it. So we're going to talk for a moment about change of base. So in the calculator, when we write a change of base, right, we go into alpha. So let's say I wanted to actually type this in right now. So alpha window 5, log base 2 of 6 minus 3. Right, I'm able to type that in. I have a special key for it. But that's not the only way you can type in a log with a base other than, let's say, 10 or e, which are the logs that are on the home screen. There's a formula called change of base, which is just another way to write this. And basically what it allows you to do is use any base logarithm. So let's just say we'll use the common log because that's one on your home screen. And this is what we call the change of base formula. And what this is actually equal to is the log base 2 of 6. So let me just confirm that. I'll show you that over here. So if you had taken a log of 6 and divided it by a log of 2. Again, I'm using the common logarithm right now, or alpha window 5, log base 2 of 6. These two things are equivalent to each other. Now, what I typed up here with the two logs dividing, I could use any log. It doesn't have to be base 10. I could do natural log of 6 divided by natural log of 2 and get the same answer. So when you have a logarithm with a base other than the number you're taking the log of, or other than 10 or e, what you're allowed to do is really split it up into a quotient, log of the input, which is really what's inside the log, in this case the 6, divided by the log of the base, and the log that you're using here can be any base you'd like. So the easiest one to use would be the common log, or ln, since they're, those keys are given to you on the home screen. So let's just, how could we have answered this question if we had no idea what I just said and we just understood the loop trick? You could have typed in the answer like we did earlier. Let's go back here. So log base 2 of 6 minus 3, we ended up with that negative 0.415. Okay, so let's just go back here. Oh, this was equal to negative I have no memory, 415. And then I could check my choices. Obviously, that's not 0. So I'm narrowing it down a bit. So I could type in natural log of 6 divided by natural log of 2. And then subtract 3. And there's my answer. So one way to get this question right is to just, do this, solve this the way we have. Type in the answer choice we got and compare it to the answers to see which ones match, and choice 1 does match. The other way is to kind of become familiar with this change of base idea, and instead of leaving our final answer like this, we could either have log of 6 divided by log 2 minus 3 equals x, or if you can see here, all the choices, they didn't use the common log, they used the natural log. So just to show you that these are equivalent. Okay, so there are some practice questions you can try now. The answer key will post with the rest of the notes by the end of today. And please just give lesson 5 homework a try tonight and submit by tomorrow.